I'm Aurèle from Télécom SudParis. In this video, we demonstrate the possibilities of our solution, the Serverless Shell, and how we can leverage the parallelism of serverless computing. So, with Serverless Shell, we adapt the Unix shell to serverless, and we are able to port shell scripts to the function of the service platform. So let's consider a base example. In this example, we want to display the root directory of a local machine with a shell command. So if you want to display the root directory of a remote serverless instance, we will just need to prefix the shell command with shell, which is our software. So the serverless shell provides support for stateful computation, which means that we use a shared object to perform parallel execution and perform synchronization using parallel semantics like a barrier. For this, we need additional components such as distributed file system or inter-process communication layer. In this example, let's consider the user working on his laptop who wants to perform parallel commands and perform synchronization on the barrier named foo. So he wants to run 3 shell commands. On the first step, he will contact the fast platform and send his command to the platform. On the second step, the platform instantiates 3 shell functions. On the third step, each instance will synchronize on the barrier foo by interacting with the inter-process communication layer implementation. Now let's consider few examples performing average calculation on a huge dataset with 2 versions, stateless and stateful versions. We are on an EC2 instance. We already built the serverless shell, and we need to deploy the function. For this, we need a configuration file. Since we run a stateful version, we need to run the implementation of inter-process communication layer on a remote machine. So on the last line of the configuration file, we fill the IP of the remote machine. Now we deploy the function. The deployment is successful. Then we test that shell is working with a simple command. There we go. Now we consider the following example. So in this example, we mine a command crawl dataset that contains internet metadata. On the first step, we download index file containing lines of archives to be processed. We process the 600 first lines of the input file. Now we have 2 versions of the average calculation. With average calculation, we download each line of archive and we search for a specific pattern. As a result, we have pattern with associated values, and we calculate final average of all the return values. With the stateless version, we use Hawk software to perform the final calculation, and with the stateful version, we use shared object counter included in a serverless shell to perform the final calculation. Now we run the stateless version. So since we process 600 lines of the index file, we will spawn 600 shell instance on the platform. Now we run the stateful version. So since the stateful version involves distributed charge objects, which involves the interprocess communication layer, that means we synchronize with a remote server running the implementation of the interprocess communication layer. There we go. So in this video, we demonstrated our solution, the serverless shell, with a few examples. Thank you very much.